Assalamu alaikum.
Welcome, Salam.
Okay, sorry about the delay. And did you watch the match yesterday?
What maths? But we have maths.
No, no, no. I mean the match between Australia and Argentina.
Oh yeah, sure. It was expected, but we did all right, even though
Pretty
we
well, I
lost.
guess. Yeah. I mean, everyone expected that Argentina would score three or four goals, maybe, but the way
We won against
Australia,
two against one, sorry.
yes,
Yeah, it was good.
so that's good. Yeah. All right. So yeah, previously I had given you some homework regarding last Atelier's principle. So did you revise them?
We have homework? Wait, what?
Yes, I gave you homeworks. Can you check your notebook? You will find this. The class notebook, you will find them there. Because you are finding difficulty in understanding these things, so that is why I gave you homeworks. Say 2 4, I guess, like the temperature principle for last atelier principle, and another
Yes, that
one
is
was
equal
for
to the
the change of
total
pressure.
internal energy.
Yes. So did
Where
you
is
check
the
them?
page? I remember where is the page?
Where is the page?
Yeah.
Don't you use like a separate notebook for my class?
Yes, but like I can't find it.
Okay, that's strange.
Oh well.
Mhm.
All I have is the last thing is pretty much about the formula for internal for temperature heat difference, and
Right,
then
yes. I
something
mean,
about mangoes. Wait, no,
mangoes.
I have
Where
no.
would the mangoes math was like in permutation combination.
Yeah,
Previous two
sorry.
classes have been on Lascelles principle, right? Anyway,
Yes,
I mean, why I wanted to do this homework because it will save some time in the class, all right? So as we get limited time, so again, I might have to explain. But let's see, let's take a quick examination of you. Not examination actually, let's say a test.
recap.
Say, say this is a both-sided reaction, okay? And you get,
Oh, I'm sorry. Just a second. My mom's calling me.
all right.
Hi.
Okay, you're back. Everything good?
Sorry. Uh, Not quite. Just family stuff.
Okay.
Anyway, I'm so sorry about that though.
Okay. All right. So, so now tell me, if this reaction is at equilibrium state, okay, what will be the effect of pressure? Okay, let me write down the question. What will be the effect of changing pressure in equilibrium state of this reaction? Here's what you have to consider. What do we mean by changing pressure? It means we can increase the pressure or we can decrease the pressure. That is what change is, right? So now tell me,
Okay,
what should be the
so
answer?
the pressure will decrease in forward reaction and increase in backward reaction.
Yes, that is correct. Now, if I change the air pressure, okay, so that is, it's given like, say, for instance, 5 atmospheric pressure, okay, all right. Now, in the equilibrium state, I increase it to 10 atmospheric pressure. Now, what will happen in that case?
Um, okay, I have to do maths now. Um,
You
it
don't have to do
would,
any maths. Remember what was
I
L'Hopital's
don't,
principle? It has to neutralize whatever the effect we put in, whatever the changes we put in, it will neutralize its effect. All right.
then the
What is the
um
neutralizing effect for increasing the pressure?
decreasing. So it would have to decrease in
So
forward
in which, yes,
direction.
right? In the
Yes,
forward reaction, the
it
pressure
would
is being
decrease.
decreased. Why? Because in the left side, you have to mention all the things, all right? Like you
Oh
have to
yeah,
write
true.
2 or 3
Sorry.
lines perhaps, but you have to mention all the things. So what do you have to say? In the left side, we have 5 moles of gaseous elements or compounds, whatever it may be. So gaseous substances, all right. And in the right side, we have 3 moles of gaseous substances, all right. So now in the forward reaction, the air pressure is being decreased, okay. So now from the L'Hopital's principle, what we know is if we increase the pressure increase the pressure in the equilibrium state, what will happen is the reaction will go or be diverted to that direction where there is a neutralizing factor of increasing the pressure. That is, in whichever direction the air pressure decreases. So in this case, in the forward reaction, the air pressure decreases. That is why the forward reaction will increase. And what will happen if I change the atmospheric pressure to say 2 atmospheric pressure from 5 to 2? What will happen? That is, I decrease the pressure.
Then the forward direction will increase.
Why the forward direction will increase?
Why will it increase actually?
Yes, that is how you have to explain it. That is when you will properly learn the things. Okay, so just figure out the steps. What do you have to do? You have to calculate the gas number of gaseous moles present in the left side and present in the right side. Then you have to see the change in the gaseous moles. Okay, in whichever side the gaseous moles are less, it has the lesser air pressure. Okay, you can understand it from the common sense, right? So
Yes.
whenever there is lesser gaseous elements or substances, there will be lesser air pressure. Now, what can we see from like left to right or in the forward reaction? The air pressure is decreasing. Okay, and in from right to left, the air pressure is increasing from 3 to 5 and 5 to 3. Understand up until now? Tell me.
Um, a bit, yeah. I'm not like a bit. I'm getting an 87% sure.
Okay, all right. So now what I am saying is, say, I mean, what did we understand from the L'Hopital's principle? It is in the equilibrium state. whatever we change, there are like three particular things. First one is like temperature. That is what we have already studied. Now we are studying air pressure, and next you will get the density or like the molarity of particular compounds. Okay, so I will come back to that as well. So now, what will happen in case of air pressure? So if I increase the air pressure, what is the neutralizing effect for increasing air pressure? Tell me. Increase
Um,
pressure, its neutralizing effect. Tell me. Neutralizing.
in forward.
No. I'm not asking that question. I mean, just think about the language, okay? I mean, what I am understanding is you are not understanding what neutralizing means here. Okay. You found some difficulty in the previous days. What is the neutralizing effect? Okay. Or the factor, whatever you want to call it, effect or factor, whatever it is. So what did I tell you? Say, for instance, um, you have spent $5. Okay. You have spent $5. Now, what is the neutralizing factor to that? It is to earn $5 because that is when you will get back to the neutral state. That is not even spending $1, not even earning $1. That is like at an equilibrium state, $0, right? That is a neutralizing factor. Understand my point? Now, again, if I give you another example of neutralizing, that is, say, for instance,
Yes.
whenever we see this reaction of acid and base, okay, whenever we are okay, can you hear me? It's showing that my internet connection is not stable. Am I audible?
Yes.
All right. Good. So
Yes.
whenever we are like making a reaction between acid and base, we get a neutralizing compound, which has some of like properties of an acid and some properties of a base. So understand the thing, like the opposite things neutralize each other. Understand my point? Like fire neutralizes water and water neutralizes fire. Okay. Pain neutralizes for happiness. So these are the neutralizing factors which keeps anything in balance. So in the neutralizing factor for increasing pressure would be, tell me,
Decreasing pressure.
decreasing pressure. So you have to understand this thing first. Otherwise, you will be stuck. You won't be able to answer anything. Okay. Decreasing pressure. So now what I was saying is that in the forward reaction, the pressure is being, tell me, you will tell me, I won't tell you. What is happening in the forward reaction?
And it's gonna increase, decrease,
How many moles of
by
gaseous
two,
substances are there in the left side,
five.
and how many in the
I
right
have
side?
three.
Three.
Wait, are you increasing or decreasing the atmospheric pressure?
I haven't
Five.
gone to that
Okay.
point either. I am
Increase.
just asking that in this reaction, what is happening? Okay, if I am
Oh,
creating
the 40.
product from the reactant, what is the change in the pressure? What is the change in the pressure?
It will.
As you can see, like there are 5 moles of gaseous substances, and in the right side, there are 3 moles of the gaseous substances. Now, obviously, we know that the more the gaseous substance, that means the more the pressure. There is no confusion in that, right?
Yes.
Yeah. Okay. So that means in the left side, we have 5 moles of gaseous substance, and in the right side, we have 3 moles of gaseous substance. That means in the right side, there is less air pressure. Is that correct?
Yes.
So if we go from left to right, isn't it decreasing the pressure?
Yes,
Is the
it
pressure?
is.
Okay, all right. All right. If you are clear with that, now again tell me, if we go from right to left, is the pressure being increased or decreased?
It's being decreased.
We're going in this direction. Consider the
Oh,
moles.
so that way, from
Yes,
3 moles to 5 moles, the pressure will
yes,
increase.
yes. Excellent. Okay. So that is how you have to go on with steps. You have to first understand how many moles of gaseous reactants and how many moles of gaseous products are present. Based on that, you have to understand in which direction the pressure is being increased and in which direction the pressure is being decreased. Now, the next step is you have to state two factors. One is, yes, if we increase the pressure, then the forward or backward reaction will increase. And if we decrease the pressure, the forward or backward reaction will increase. Okay. And how am I going to figure out that? That is, if I increase the pressure, that's neutralizing factor is decreasing the pressure. So say for instance, if I change the air pressure from 5 to 10, that means I'm increasing the pressure, right? And what is the neutralizing factor? Am I audible? Okay. So can you hear me?
What happened?
I
I
just
can
glitched
hear
out.
you
Okay.
now.
All right. Anyway, so
Okay, I can't hear you.
can you hear me now? One, two, three. Hello, hello, hello.
Well, you were kind of chopping,
I'm dropping. All right.
but you were kind of like,
Understand. But
can you hear me?
I again switched to data. I don't know what should I do. So then, is it clearer now? Maybe it sometimes takes some time to adjust. Can you hear me
It's
now?
clearer, but I can hear you now.
Okay.
Yeah.
All
Oh,
right. If
okay.
you.
So the equation. I get how. Okay, I get how. Um, if it like increases or decreases in their reaction, forward and
Mhm,
backward. But I'm guessing I'm having a little bit of trouble on neutralizing factor. So if we increase the reaction by 5 atmospheric pressure.
mhm.
Okay, first of all, can you please like solidify what is atmospheric pressure? Is it like
Atmospheric pressure.
condensing
Okay.
the
All right. Um, I mean, that's not important part of the point, but still, I'm like tell you. Say, for instance, whenever we are working with any sort of reaction, okay, uh, not all the reactions in the environment or say in the laboratory will just happen without anything. Okay, there will be certain reactions which does not involve any sort of pressure, air pressure. Okay, without pressure, you might say get the reaction of say calcium oxide plus carbon dioxide. Okay, or maybe the atmospheric pressure is say in the environment, whatever is in the environment, we don't change it at all. Okay, but there are certain sort of reactions where you need to introduce say like custom air pressures. Okay, say for instance, if what do we consider to be the natural air pressure, that is 1 atmospheric pressure, right? You know that it is the
yes.
basic air pressure in the like environment, or as you can say in the like say sea level, as you would say.
Yes.
Anyway, so we just like for generalizing, we consider it 1 atm atmospheric pressure, or sometimes we call it 760 millimeter mercury pressure, and so on, so on. Okay. So now, for some cases or some reactions, this pressure is not enough, or maybe this pressure sometimes might be like more than what we need. So for that, we have to design some sort of system where we increase the air pressure or maybe decrease the air pressure to make the reaction more effective or make the production the most efficient. Okay, because whatever we are saying is related to like producing in the most efficient way. All right, the Lashatle's principle is involved with like making the best use of the resources. Okay, to be very fair. Okay, we are considering or trying to get that particular environment in which we will get the best possible production. Okay, so for that, if we need 10 atmospheric pressure, we will insert that. If we need 20 atmospheric pressure, we will insert that. If we need 40 atmospheric pressure, we will insert that. Okay, all right. So if you will do
Um,
some like laboratory works, you will like understand how to uh, like change the air pressure or something. Okay, but I cannot show it to
uh,
you here. Okay, there are like some
yes.
machines and equipment which change the atmospheric pressures. But I don't know if you would be like familiarized with them in the college level. That is not the university level. We did not particularly do that. Okay. All right. So anyway,
Okay.
so are you clear with the idea of atmospheric pressure or what it does in this case?
Um, a
Or
bit.
okay, so can you repeat the question again?
Like
So
like for example, how if you increase the temperature, it will get hotter. If you
mhm.
increase the um like amount, it will do something different.
Right.
What would happen if we increase the atmosphere? Will it get like denser or something?
What will happen? Okay, see, I mean, that is what was the all the point. Okay, all right. See, increasing the air pressure. Okay, so how do I explain? Say, for instance, if you consider this system, okay, say this is a bucket, all right. This is a bucket, all right. Say, whenever you close this system, this is an enclosed chamber. And what do we know about enclosed chamber? That is, it's filled with air molecules. Is that correct?
Yes.
It's filled with air molecule and it has a certain pressure. All right. Now consider I am with say, for instance, you have seen a soccer ball or football, right? Is it correct?
Yes.
Obviously, you have seen that. So now what happens while we pump a soccer ball? Okay, so there is a sort of nozzle or something like a hole, and we insert something here, okay, and then press it. So then we insert air into it. Okay, that means whatever like there were air molecules pressure, based on like the increasing pressure, like we are inserting air in a particular system or say a container where it is already filled with air. Is it correct?
Yes.
Anything which is enclosed is filled with air. We have read that in say like elements or substances whenever we read basic chemistry. You've been reading it for like 3 or 4 years, maybe. Is that clear to you?
So it's just increasing the density in the air.
You could say that, yes. It's increasing the density in the air. All right. Okay. So now, uh, if you like keep on increasing the pressure, like say for instance, till the I mean it is filled with I mean no amount of air is possible to like hold. So what will happen? It will burst out. Okay.
True.
So that is like a practical example I tried to give you about what air pressure looks like or what is the role of air pressure. Okay. So it's more related to physics rather than chemistry. Okay. Like
Mm.
what is the role of the pressure, and you will do even maths regarding air pressure. If you find interest, I can start the next chapter based on pressure. Okay, all right. You will see some formulas for Archimedes and other physicists as well. So if you have you studied about what do you call it? Water, not water's density actually, buoyancy, right? That is a term. Have you studied this thing? That is, you
A
could call
bit,
the
I
pressure
think.
of liquids. Okay. I'm just simplifying things. It's not actually that. But you could say it's the like pressure of liquids. So now what is the application of that? Say for instance, you are moving in the river, okay, with a boat. How does it move? How do you think it balances itself?
It would by floating.
Yes. When does it float? Okay. When does it float? It floats when whatever the amount or like the force of the boat is given, like this say vertically, it equals to the amount of water. Say for instance, it cuts away some water, right? In these phases, right? Whenever you
Yes.
row the boat, it cuts away some water. So the sideward force of these and the like the force the boat inserts, they have to be equal. That is how the boat floats. Okay. So for instance, if you say insert say 50 people in a boat which has a capacity of 20 people, what will happen? The boat will go down. Okay. So this is particular the concept of buoyancy, which is the like pressure of liquids. So we'll study that, but we actually study that in physics. Okay. We actually had two like chapters dedicated to air pressure and how air works in physics. Okay. Like two big chapters in the HSC level or like college level. Okay. So whatever the atmospheric pressure is, that is not like part of the concern in whenever we are doing like laboratory reactions. Okay, but we will study that. Obviously, we will study that, inshallah. Okay. All right. We are not like progressing. Right. Okay, let me get back to the question. All right. So where was I? I was saying about neutralizing factors. Okay. So increasing pressures, neutralizing factor is decreasing pressure. Are you okay with the neutralizing factors? This is just like understanding languages. Okay.
Yes.
Okay. So what I was saying is, say this is 5 atmospheric pressure. This has been inserted in the system. Okay. And the other thing, what you have to see is
Yes.
how many moles of gaseous substances are there. Here it is 5 moles, and here it is 3 moles. Okay. Now, based on that, I understand that with all the things I have like inserted in the system, say this 5 atmospheric pressure, maybe some temperatures and some reactants, it creates some products. Okay. Now, whenever the reactant is turning into a product, whenever the reactant is turning into a product, the air pressure is being decreased because the number of moles of gaseous substance is decreasing. Understanding my point? Is it clear up until now?
Yes. Yes.
Okay. So now, according to the La Chatelier's principle, if we increase the air pressure, what should it do? What is the neutralizing factor to increasing the air pressure?
Decreasing the air pressure.
Decreasing the air pressure. So, yeah, if when you figure out that, okay, if I increase the air pressure, the neutralizing factor to that is decreasing the air pressure. Okay, decreasing the pressure. So then what you have to do? What you have to do is just figure out in which direction the air pressure is being decreased. Tell me in which direction.
Um, you would be increasing to the forward,
Okay, so the forward reaction increases.
backwards,
Okay,
forwards. Yes.
reaction increases.
And it would decrease pressure in backwards.
So if I no, it won't like decrease pressure. It's like the
So it
effect
would
of
increase on
decreasing
both
pressure.
sides,
So
but
I
decrease pressure.
personally is as a like lab operator, I am decreasing the pressure. I will intentionally decrease the pressure. And what will be the effect to that? That will be the neutralizing effect. And what is that? That is increase the pressure. Okay. And in which direction will it happen? It will happen in the backward by back increasing the backward reaction. Backward
Yes.
reaction increases. See, I'm not saying that you have to understand everything at first sight. Okay. But whenever, even if you would have like given 20 minutes in the homework, what would happen is, okay, whenever you are not understanding that thing, you will like do some brainstorming or try to understand what might happen. Okay. In that way, you move towards like proper and sustainable learning. Okay. That stays in the brain for like say years after years. There is a saying in our Bengali that is, whoever is properly educated is self-educated. Okay. So, like, whoever is learning, not educated, say it's learning. Okay, whoever is properly learned or properly learned something, he does like self-learning. Okay, understand my point. So, invest some time in the homeworks. Okay, it will be better for you.
Hmm.
Okay, all right. So, please tell me, is there anything unclear up until now regarding air pressure?
No.
Okay, all right. I hope you remember what happens in like increasing temperature or decreasing temperature. Is that correct? Oh,
Yes. I hope
okay.
so too.
Okay. Okay, so let me give you another link. Just join first. Okay. All right. Let's try to finish the other component as well.